Hey everybody, Bob here. Usually it's Wrenchin with Bob. I'm going to say Burnin-with-Bob. So I'm working on RoboSwamp, the ultimate crazy over-engineered swamp cooler. Getting ready to take it to 2022 burn.
All right. Hey everybody, I'm RoboBob. And let's talk a little bit about swamp cooler basics. And then I'm going to give a tour of my incantation of a swamp cooler that I call RoboSwamp. So what is a swamp cooler or an evaporative cooler? Air conditioners, require big time power in order to cool air. And they're not very playa friendly. But a swamp cooler does not. And it's great in the middle of a desert. So super. How does it work? It's pretty simple, really. Basically, water is used at the top here to soak, sort of dropped onto a pad or a membrane. And that water then soaks that membrane. And then a fan is used to pull air through that membrane. And so it brings in that hot, dry air on the left-hand side. And when the air comes through the pad, it'll get colder by virtue of evaporative cooling effects. And this is pretty similar to the way that our bodies cool by sweating. And we've all kind of experienced this sense of extra coolness when we get out of the pool or we get out of a shower and we've got water on our bodies, whether it's sweat or it's water, and we feel that air creating this evaporative cooling effect. And so it feels kind of super cooled. So swamp coolers, what do they need in order to function well? They need low humidity, and so they don't work well in high humidity areas. And this is why people in the South, like Florida and stuff, they don't often know what a swamp cooler is because they don't work well there. So they don't exist. But in Arizona and in Nevada and some parts of California, that swamp coolers are used, or evaporative coolers are used. They also need water. They're kind of hungry for water, in fact, because as the evaporative cooling happens, there's evaporation, right? The water evaporates. And so you do need water. And so that will mean you'll need to bring extra water up to playa. They also need this pad or a membrane that's going to hold the water in suspension so that the air can pass through it, cause the evaporation, and cause the cooling effect. And then sort of lastly, the last two items are that you need a fan, right? A fan or fans to pull that air through the pad. And then you're also going to need to recapture as much water of that as you can. So as it drips off that membrane, it needs to be pumped back up into into the pad to be used again. So how much of a fan is required? This is where there's some math to be done if you want to kind of optimize this deal. So you're going to figure out what the cubic feet of your living space is, and this is going to be the basis for how many cubic feet per minute of air you need out of your fans. And so basically the rule is you want to change out the air inside of this space that you're trying to cool in less than 4 minutes, or there's just kind of not much cooling effect. It just won't be very effective. And preferably faster than that, right? So somewhere between, let's say, 2 and 4 minutes. So basically what you do is you calculate the cubic feet inside of your area, and you don't have to be super precise, but you could figure out the inside area of your RV or of your tent in rough numbers, by feet by feet by feet, and that's a cubic foot. And then don't count cabinets and closed off areas and stuff like that, because that airspace that's in that little chunk of area in that cubit isn't going to be cooled. And then basically you take that number and you divide that number by the number of minutes that you want to have a complete air change out. And so at most divide this by 4, but preferably divide it by 2. Do it twice. Divided by 2, divided by 4, and basically that's your range, right? That's kind of the total number of cubic feet per minute that your fans need to deliver in terms of performance. And fans usually have a spec that says CFMs. So it's pretty convenient. And so like in this example here, if you've got a 500 cubic foot area of space that you want to cool, and you divide that by 4 minutes, you're going to get 125 cubic feet per minute. And that's a pretty modest fan. And if you, and of course, if you had 1,000 cubic feet, it's going to be double that, right? It's going to be 250 cubic feet per minute for that 4-minute change out. And, or better yet, if you've got that same 500 cubic feet of space and you want to change it out in 2 minutes, it's going to take you twice as much fan, right? So 250 cubic feet per minute for that 500 cubic feet of area. So in this particular, instance with 500 cubic feet of space, right, you'd want fans that would be between 125 and 250 cubic feet per minute of airflow in order to do the job and do an effective job, right? There's not magic here, right? It's a range, and it's a matter of effectiveness. And then how much water is required? This one's a little fuzzier. Water gets used when it evaporates, and so a lot of this depends on how fast you're changing out the air, so how much air you're pushing through that wet membrane, and how much air you have to change out, and how soaked the pad is. These are all going to be things that determine how much water gets used. And so, yeah, that's not very helpful. So, sort of as a rule of thumb, for like a Class C RV, a smaller Class C RV, like a 25-footer or so, you can expect between a half gallon and a gallon per hour, roughly. And so, you can control some of this, right? If you find out that you're using a lot of water, you can dial down the fan speed if you've got the ability to do that, or use it less often, and have less water be consumed. All right, what can I expect in terms of cooling? Right, this is what really matters. Why bother if you don't really get some cooling? In a low humidity environment like Burning Man in the desert, we're talking about low humidity, like single digits humidity. In such a dry environment, you can really get some significant cooling with very little power. And so like 10 to 15 degrees, even as much as 20 degrees of cooling. So, that's quite significant, right? If you've got a 100-degree day and you could get away from that heat for a little while to cool down and have an 85-degree space, then that's a wonderful thing. All right. So let's go. Let's go take a tour of what RoboSwamp 1.0 looks like, and I'll tell you how well or not well it worked for me in 2022, and the types of things that I'm going to try to do to improve it for 2023.
The project that's been going on for quite a while is this thing called RoboSwamp, and it's a swamp cooler extraordinaire. So it's over-engineered. Cost is not the issue, only performance. So low power and lots of features. So today is the first real setup of it at the RV rig itself. It's a windy day. Hopefully the microphone doesn't do terrible things. So what we've got over here is we've got the box that holds the six gallon water bucket. So I've got maybe 3 gallons of water in here, and it'll only hold like 4 or 5 based upon this hole, which is a return hole. So the bucket goes in there, and then this whole widget here goes in the bottom of that, which has got obviously a little aquarium water pump on it. And then it's got some sensors on there as well for temperature and for sensing when the water is low or when the water is out. And all those control lines and stuff come out the side of the bucket there, or the box, and head up to the window, which is where we're going to mount the fans that actually blow the air in. There's actually a bonus fan up underneath here to add some pressure to the whole system. Since basically what you're doing for a swamp cooler is you're wetting this pad with water. And so that pump goes up this line here, and then it goes up to this here, which has a bunch of holes along the way for it to spritz out water. And as it spritzes out that water, it's going to hit the pad here, soak the pad, and then the air draw that's drawing up that tube is going to draw air through the big hole here on the other side, which will have a grill on it, and then so the cool air comes in with evaporative cooling across that, and then the return through the gutter, when the water is returned that hasn't evaporated, is returned back into the bucket to make it hopefully a closed system.
All right, so without the wind. So this section here, this is what goes into the window, and so this has got two PC fans, they're 140 millimeter fans, and this is cowling that I designed on CAD and printed on a 3D printer. And here at this juncture here is where that 6-inch AC ducting work gets attached to it. All right, and then this part here, this is the part that sits on the counter. This is where all the compute stuff is and where all the power management stuff and circuitry is. So that's pretty much the way that works.
And stuff. Like I said, it's over-engineered. That's part of the point. It is over-engineered. All right, so I'm going to set it up and get this thing rolling so I can see if it's actually effective. This won't be a perfect simulation because, for one, it's not a terribly hot day, but more importantly, the humidity here in Northern California is quite a bit higher than it is in the desert, so the effectiveness of a swamp cooler is directly proportional to the humidity. So we'll see how well it does today. That's the point. But here we are inside the rig. And so what we have here is those two PC fans here, and there's one hole down at the bottom here for all the wires to come through, and they all came through except for one doggone power wire because I forgot how wide this connector is. Anyway, so there's where the airflow comes in. Here's the controller, and the back on this one, the snap broke off unfortunately, so it doesn't fit nicely and it's not the right colors, blah blah blah. But that's ready to be powered on, and let me take a quick tour outside before I turn the thing on. Right, we have up in the window, right, and then we follow that down, the tubing down to the big box with the bucket in it. And this actually will have a grill on it, like an air return grill, but I just don't want to use these screw holes more often than I need to, so I didn't bother with that today. And then for service, when I need more water, there's a little latch over here, and everything got printed over here. So that guy opens up, and you've got access down here to fill with water, and possibly even put ice in it if the ice blocks will fit, or if we can smash the ice blocks to make them fit. Anyway, cooler water would make for cooler airflow. So let's power this thing up and see how it goes. All right. There we are, RoboSwamp powering up, doing some self-tests. And all the tests passed, hooray. So it sees all the temperature sensors and all that jazz. And this is actually a touchscreen display, so I can turn the fans on and off by touching here. That's low, medium, and high. And you'll see here that it shows that we're 78 degrees inside with 46% humidity. It's an unfortunate amount of humidity today. And then that it's 1 degree hotter outside than it is inside. Then I'm going to kind of go into a mode here to be able to turn on pumps and stuff and check temperatures. So I've got a whole bunch of little temperatures and stuff across the bottom here. And we'll turn on the water. Turn that on full blast to get the pad wet, and then of course I'm going to have to check and make sure the water is staying where the water is supposed to stay. But basically what we're going to see at some point, and I'll come back and video this in a little while, is that the outside temperature is going to stay, warmer, and that we've got a water temp here of 72, so that's already cooler than outside, and then a fan temperature as it enters the building here at 75. And the internal temperature, which is taken off of a different sensor, not sitting right by the fan, is at 78. So I'm really curious to see how all that goes and how it progresses over the next hour or two or three, however long we're here.
All right, so let's do a little post-mortem and picture show here at the end. So this is what it looked like on playa, hooked up to the rig, getting dusty. And there you can see the bucket as well. And a little wider shot from the outside of the rig, all set up. And there's the the device on the counter. And afterwards, taking a look at the dust, of course. And this is what the circuit board looked like. I did design the circuit board and the PCB and all that jazz as well. So in terms of how did it work, because that's all that really matters, right? In terms of how it worked, it was okay. It certainly helped, but it was not what I had anticipated. And I think, frankly, that's my fault. I had a tough time doing water management. And so I think ultimately I didn't soak the pad enough. I think I had enough airflow, but for this go around in 2023, I'm going to attempt to do water management better, soak the pad better, and I may put a beefier fan on it, which will make it less efficient, but will work better. So that's the deal.